Okay, for business, understanding the demand for its product is very important. Uh, so how can we find out what's the demand for my, or how can we quantitatively estimate a demand function for my product? This is what we want to cover today. But before we start estimating a demand function for my product, we need to cover the methods of doing so. Okay, I'm going to draw a diagram here. I'm going to call vertical axis y. I'm going to call horizontal axis x, and their data point like this. Okay, by looking at this diagram here, it is reasonable that we know that there exists a relationship between y and x. Y depends on x somehow. Okay, so I want to estimate this relationship, or estimate y as a function of x from the data. How can I do this? Okay, let me draw a line here. Okay. So would you agree that this line, the red line I draw, possibly fit the data nicely? Okay, seems so. Okay, so let me draw another line. So now the second line I draw is black line. Okay, so this black line also fits the data, the green cross, data points in a way. Then here comes the questions. Can we say which one, red line or black line, fit the data in a better way? Okay, to say so, we now need to have a yardstick, a criteria. Okay. Let me erase these black lines for a moment. Okay. Look at these red lines and its relation with the data point, the green cross. Certainly, it cannot pass through all the data points, right? There's no way of fitting this. Okay, so let's look at this point. Oops, sorry. For this point, the corresponding x is at this level, corresponding y is at this level. However, according to the red line, we go from the x up. Let me call it x0, y0. Okay. Go from x0 up to the red line. We read out it's called y hat. Read out is the associated y. We know that there's error here. There's error here. So that's the error for this point. There could be like for this point. There's another error here. And you should know that for this, let me call this point B, this point A. For point B, the error is positive. For point the error is negative, right? So now our tasks, we want to fit the lines to the data points in the best way. And we know that this line cannot go through all the data points. So there always exist errors. And these errors can be positive, can be negative. So what about, let's do it this way. Let's choose the line. Choose a line that minimize sum of squared error. So first, we squared. Remember, we have positive error, we have negative errors. So first, squared, get rid of all the square negative signs. Then add them up, add all over these data points. Then choose a line. Okay, but to minimize this sum of errors, by saying choosing a lines means that, okay, we gotta set the in empirical models. So y is equal to a plus b times x, and a and b, they are unknown parameters we want to estimate from the data we have here. Okay, so by saying choosing a lines, we are saying choose a and b. Choosing A and B. Okay, yes, this is one method that we can use to estimate the functional relationship between x and y from the data points. And we call this ordinary least square estimator, or OLS. Okay. So that's the method we want to use in estimating demand function. So here I will use Excel to illustrate the OLS estimations regressions. I'm going to first generate a data set. Because I generate a data set, I know all the values of parameters. Then using these generated data sets to run an OLS regression. And if I'm correct, the estimated parameters should be the same, should be close to true values. Okay, so the data generating process is y is equal to a plus b times x plus errors. Okay. So a, let me put it to be 2. B is 0.5. Okay, x and error. Okay, because I'm generating an hypothetical data set, so I know all the errors. In reality, you don't know this. Okay. Okay, I'm going to use data menu here, the data analysis. Sometimes in your Excel, you might not have this function, which means you haven't installed this function in your Excel. So to install this, you need to go to File, More, Options, Add-in, Excel Add-in, and make sure you click this Analysis Toolpack. I already clicked it, so you see this function in the ribbon. Okay, let me unclick it, unselect it. It disappeared. Okay, I'm going to click this data analysis. There are quite a few functions in the pop-up windows. What I need here is random number generation. Okay, I'm going to generate two variables. One is x, the other is error. And with 100 observations from normal distribution, standard normal distribution, mean 0, standard deviation of 1. And let me put the C's. So these C's will make sure that we are able to replicate the results later on. And output range, output from here. Output the data from A5. There you go. Then I construct Y. So Y is equal to A, so which is B2, $B, $2. I'm using $sign to fix the referencing. Plus B, $B, $3 times X, which is A5, plus the errors, so which is B5. Okay. Okay, in reality, I do not observe this error, so I'm going to get rid of it. I'm going to just make it invisible. Okay. We can actually draw a scatter plot of X and Y and see what it looked like. So something like this. And we want to fit lines of this into this chart. Okay. So now we want to regress Y against X. I'm going to use this data analysis function as well. Data. So now the function I'm going to use is regression. Choose the regression. Input Y, which is dependent variables, is here. Input X, which is independent variables, is here. And you should note that my selection includes labels. So I'm going to click here to tell Excel that my selection includes labels. Everything else you can leave there. So I'll put the results in here. So, okay. So there you go. The intercept here is our A, estimate of A. The X is the coefficient of X, is the estimate of B. So it's B here. And we can clearly see that it is close to the true values. So A is 1.8679, close to 2. B is 0.5817, close to 0.5. Okay, let's using this estimation, let's generate the Y hat. Let's call it Y hat. So it's equal to intercept, so which is G17, and let me use dollar to fix the difference. Plus G18 times A5. So that's the predicted value according to our estimation. Oops. Yeah. A5, sorry. $18. Right, okay. And let's draw a scatter plot of this. You can see that this orange dot is actually the straight line we fit into the blue points.